Ever wondered how a diesel engine works? Well, buckle up, because we're about to embark on a fascinating journey into the heart of these mechanical beasts. Diesel engines, named after the German engineer Rudolf Diesel, are a cornerstone of the automotive and industrial world. They power everything from trucks and buses to ships and generators. At their core, diesel engines are internal combustion engines, just like their gasoline counterparts. However, they function a bit differently. They're made up of several key components, including the cylinders, pistons, and fuel injector, all working in harmony to convert fuel into motion. Their robustness, efficiency, and torque output make them the engine of choice for heavy-duty applications. But how exactly do these components come together to make a diesel engine work? What magic happens inside that metal block? By the end of this video, you'll have a clear understanding of how diesel engines function. So let's get started, shall we? At the heart of a diesel engine is the four-stroke cycle. A fascinating process, it functions as the core of how engines bring our vehicles to life. Our journey begins with the intake stroke. This is where the piston starts at the top of the cylinder and moves downward, creating a vacuum that draws in air. Imagine a deep breath in, filling your lungs with air. That's essentially what our engine is doing. Next up, we have the compression stroke. The piston reversely moves upwards, compressing the air in the cylinder, which heats it up significantly. Think of this as the build-up before the grand spectacle, the tension before the climax. This leads us to the grand spectacle itself, the combustion stroke, or as some might call it, the power stroke. At the top of the compression stroke, fuel is injected into the cylinder by the fuel injector and is instantly ignited by the high temperature of the air. This explosion pushes the piston downwards, creating power that turns the engine's crankshaft. It's like the engine's personal firework display, creating a powerful force that propels us forward. Finally, we arrive at the exhaust stroke. Here, the piston moves back upwards once more, pushing out the spent gases or exhaust through the exhaust valve. It's a cleanup operation, if you will, preparing the stage for the process to start all over again. It's a captivating dance, a cycle that repeats itself over and over, each round creating more power to drive the engine. Each stroke playing a crucial role in this well-orchestrated symphony of power generation. These four strokes work in harmony, each relying on the other to function. They bring together the principles of physics, thermodynamics, and mechanical engineering to create a machine that powers our world. And that's the four-stroke cycle, the pulse of every diesel engine. A marvel of engineering, don't you think? It's a process that takes mere seconds to complete, but the power it generates is nothing short of astounding. Now, let's dive into the critical step of fuel injection and combustion. As we journey into the heart of a diesel engine, we encounter a crucial process that brings life to these mechanical beasts, the fuel injection and combustion. This process is a symphony of precision, power, and timing. Fuel injection in a diesel engine is a high-pressure affair. It starts with the fuel pump, which pushes diesel fuel into the fuel injectors. These injectors are like gatekeepers, waiting for the perfect moment to unleash a fine mist of fuel into the cylinder. Now, the stage is set. The cylinder is filled with compressed air, hot and ready for action. The fuel injector sprays in the diesel, and the magic begins. The heat of the air ignites the fuel immediately, causing it to combust. This combustion produces an intense burst of energy, forcing the piston downward. This is the power stroke, the moment where potential energy transforms into kinetic energy. The downward thrust of the piston turns the engine's crankshaft, and this motion is what eventually powers your vehicle. But what makes this process unique in a diesel engine? It's the method of ignition. Unlike gasoline engines, which need spark plugs to ignite the fuel, diesel engines rely on the heat produced by air compression for ignition. This method, known as compression ignition, is the heart and soul of a diesel engine, and it's this ignition process that gives diesel engines their renowned efficiency and torque. When the fuel combusts at higher compression ratios, it creates more force, pushing the piston down with greater power. This leads to more torque being delivered to the wheels, giving diesel engines their characteristic grunt and pull. But remember, all this happens in a fraction of a second, over and over again. thousands of times per minute. It's a testament to the marvel of engineering that is the diesel engine. This combustion process is what sets diesel engines apart from other types of engines. It's the fire within that breathes life into these machines, and it's the reason why diesel engines have powered our world for over a century. But why are diesel engines so efficient? That's the question we're going to tackle in this segment. The efficiency of diesel engines is largely due to their high compression ratio. The compression ratio is the difference between the volume of a cylinder when its piston is at the bottom and the volume when the piston is at the top. In other words, it's the amount by which the air-fuel mixture is compressed before it's ignited. This ratio is much higher in diesel engines than in petrol ones. We're talking somewhere in the region of 20:1 compared to about 9:1 for petrol engines. And this difference is crucial in terms of efficiency and power. You see, when you compress a gas, you increase its temperature. So, in a diesel engine, the air gets hot enough to ignite the diesel fuel without the need for a spark plug. This is known as compression ignition, and it's one of the key factors that make diesel engines more efficient. Moreover, the high compression ratio allows a diesel engine to extract more energy from a given amount of fuel. This is because the greater the compression, the more heat is generated, and the more heat, the more potential energy is available to push the piston down and turn the crankshaft. But that's not all. Because diesel fuel is denser than petrol, it contains more potential energy per liter. So not only does a diesel engine squeeze more power out of each drop of fuel, it also gets more drops per liter in the first place. To sum up, the high compression ratio of diesel engines leads to greater efficiency and power. They use compression ignition to extract more energy from the fuel, and because diesel fuel is denser than petrol, they can get more power from each liter. So now you know why diesel engines are the powerhouse they are. Like everything else, diesel engines have their pros and cons. Let's dive right in with the advantages. One of the most notable merits of diesel engines is their incredible fuel efficiency. Diesel fuel contains more usable energy than gasoline, meaning you can travel farther on a gallon of diesel than you can on a gallon of gas. That's a major plus for long-haul truckers and anyone else who spends a lot of time on the road. Next up, durability. Diesel engines are typically more robust and reliable than their gasoline counterparts. The lack of an electrical ignition system reduces the chance of engine failure, and the high compression ratios make these engines tough as nails. In fact, with proper maintenance, a diesel engine can run for several 100,000 miles without skipping a beat. But wait, there's more. Diesel engines also offer greater torque. This means they can handle heavier loads and tougher tasks, making them a go-to choice for heavy-duty vehicles like trucks, buses, and construction equipment. Now let's switch gears and talk about the disadvantages. One major downside of diesel engines is their environmental impact. While they are more fuel efficient, they also tend to emit higher levels of pollutants like nitrogen oxides and particulates. This has led to strict emission regulations in many parts of the world, making diesel engines less popular in some markets. Moreover, diesel engines generally have a higher upfront cost than gasoline engines. The complex technology and sturdy build quality that make these engines so durable and efficient also make them more expensive to produce and purchase. Lastly, diesel engines can be a bit noisy. The high compression ratios that give these engines their power and efficiency also result in increased engine noise. However, advancements in technology have significantly reduced this issue in recent years. Weighing the pros and cons, you can see why diesel engines are a popular choice in heavy-duty vehicles. So, let's recap what we've learned today. We began our journey by understanding the basics of diesel engines, diving into the heart of these powerhouses, the four-stroke cycle. We explored how each stroke, namely intake, compression, combustion, and exhaust, play a pivotal role in the engine's functioning. Next, we delved into the intricacies of fuel injection and combustion. We saw how the precise timing and pressure of fuel injection, coupled with the heat of compressed air, leads to efficient combustion, the driving force behind these engines. We also touched upon the notable efficiency of diesel engines and how their high compression ratio and lean burn allows them to use less fuel and deliver more torque than their gasoline counterparts. Finally, we weighed the pros and cons of diesel engines, acknowledging their fuel efficiency and longevity, but also considering their emissions and noise issues. And that, my friends, is the fascinating world of diesel engines. Thank you for watching, and if you enjoyed this video, don't forget to like, subscribe, and share.